Hello, this is Dr. Lori. Welcome to this video on how to conduct the one-way ANOVA in SPSS. To get started, we'll need to open a new data set. So we'll click on File, New, Data. That opens us a brand new data file. And the first thing we like to do is to go to Variable View and to type the names of our variables in. So in this particular case, we're going to be looking at the expenditures on 5 different Forest Service trail maintenance projects, and to see if the same amount of money is being spent on each one. So you can imagine this applying to public health, where we're looking to see how much money is being spent on different parts of a project or even different projects. So the same kind of theory would apply. So the first column of data under variable view is going to be called dollars. And the label for this is going to be dollars in thousands. Remember, the label is something that we try to add so that it'll help people understand exactly what it is that we're showing them. Spent on trail maintenance. Okay. The second one, the second variable is which trail it is. And we have 5 different trails that we're going to be looking at. And then over here under label, we'll type name of trail. So in this case, this is a categorical variable, and we're going to be coding it as we go through. So we need to tell SPSS what those different coding variable values will be. So number 1 is going to be for Eaton Canyon. Click add. Number 2 is going to be for Grizzly Flat. Number 3 will be for Rattlesnake. Number 4 will be for Bailey Canyon. And number 5 will be for Millard Canyon. Hope I spelled all those right. So now, anytime we make a graph or a table, those categories will be labeled with the correct canyon rather than just saying 1, 2, 3, 4, 5, which is really what we're after. And these labels also that we've typed in, instead of just saying dollars and trail, the label, whatever it is that we've decided is important to include, is going to be included on those graphs or tables or charts. So now we can go to the data view and enter our data. So we need all of the dollars and all of the trails. Each trail was measured 6 times, 6 different years. And so if we have 5 trails times 6, we should have 30 different rows of data. And what I've done is I've entered it in here so that it's faster. You could just enter those numbers directly in to the SPSS program. So here's my first group. And those are on trail number 1. Let me do this. I can go back and forth a little easier. There's my second group. Here's my third trail. Rattlesnake is trail number 3. 3, 3, 3, 3, 3, 3. Bailey Canyon. Is a 4. And then Millard Canyon. And I have my 30 lines of data. So what you end up seeing here is that each row represents a unit, whatever that case is, and this happens to be the trail being measured, like the amount of dollars that were spent on a trail during a given year. And then we need a second column that is our grouping variable, similar to what we did in our independent samples t-test in a different video, but in this case we have 5 different groups or categories. Now it's important to notice that this scale variable, one of the assumptions for a one-way ANOVA is that the scale variable should be normally distributed, and each group should have approximately the same variance, and we're going to see if that holds up when we conduct this test. So here we have each row represents a case, which is a dollar amount that's spent on a trail, and we measured that for each trail for each year only one time. So then we're going to enter that in so that it's set up this way. So then I'm going to save this data set, and I'm going to call it the same thing they do. Trail. Cleverly named trail. All right, so now my data set is saved. So the next thing we're going to do is we're going to actually do the one-way ANOVA test now that we have our data all entered in. And the way we do that is under Analyze, Compare Means, and One-Way ANOVA. And the fact that one-way ANOVA is here with the paired t-test, the independent t-test, the one-sample t-test gives us a clue that this is a test that is similar to those other tests. And indeed, when we look at our table that shows them, they all happen to be on that top row. They all have a continuous variable as an outcome variable. So Analyze, Compare Means, one-way ANOVA, and our dependent variable is dollars. Dependent is going to be our continuous variable, and factor is a fancy word for categorical variable. So trail has categories. So we're going to use that as our factorial variable. And then one more thing that we're going to do now that we have 3 or more categories is we're going to add something in called post hoc tests. And specifically, we're going to ask for the Scheffé test. The fact that you see so many different options means that there were a whole bunch of people that came up with different ideas of how these post hoc multiple comparison tests should be conducted. So we're just choosing one of them, and then we'll click on the Continue button, and we have our variables all entered in here, and we'll click on OK. Now, the data that we get for a one-way ANOVA is more complicated than a one or an independent samples t-test. And the reason for that is that now we're not just looking at 2 different groups, we're looking at multiple different groups. So instead of getting the output that we saw on the independent samples t-test, we get something called an Anova table. And the 2 important variables that you need to look at here are called the F test and the p-value, or the significance value. And so it calculates a mean for each group. And you can see, actually I didn't ask for the means. I would have had to have clicked on something extra in order to do that. Let me show you where that is. Analyze, Compare Means, one-way ANOVA. Here under, no, it's not under Contrast, never mind. Oh, Options. Descriptive, there we go. So if I were to do this again, I'll get more data, even more data. So this first table gives me the mean for each of those different groups. So the average trail maintenance spent on Eaton Canyon was close to 20,000. Grizzly Flat was about 10. Rattlesnake was closer to 7 or 8. Bailey Canyon was a little over 5, and then Millard Canyon was 14. So it looks like they're different. And my overall hypothesis, my overall F test that is here, it tests whether mean 1 is equal to mean 2 is equal to mean 3 is equal to mean 4 is equal to mean 5. All the means are equal to each other. And we can see, based on this p-value, that we do not think that's the case. We think that it's something else. So we're going to reject that null. And the interesting thing about the one-way ANOVA test is that the alternative hypothesis is that at least one mean is different. Not all of them are the same. It could be there's just that one is different from all the rest, or one is different than one other one. So once we make that decision to reject the null based on this overall F test and the p-value that goes along with it, then we can go and look at the multiple comparisons test. And what this table does is it tells us for all possible combinations, what is the difference. And so even for this first one, Eaton Canyon compared to Grizzly Flat, that looks like it's a significant difference. Eaton Canyon compared to Rattlesnake and Bailey, those two also look like they are significantly different from each other. But Eaton Canyon and Millard, not different. So if we go back up here and we look at our Eaton Canyon and Millard, looks like 19 and 14. It looks different, but our question is, are they statistically significantly different from each other? And this down here is telling us no. In fact, 19 and 14 are not significantly different from each other. 19 is significantly different from 10, 8, and 5, but not significantly different from 14. And we can go through all the other different possible combinations. Grizzly compared to Eaton, that actually should be the same as Eaton compared to Grizzly. So it looks like a lot of comparisons, but they're all duplicated. So that p-value is identical because it is the same. But now we get to see Grizzly compared to Rattlesnake and Grizzly compared to the other two. And we can see that it is not different from those particular, like the expenditures aren't different. So we can isolate, by looking through this table, we can isolate which expenditures are different from which other ones by looking at those p-values. Now to reiterate, we would never even look at this multiple comparisons table if this overall F and the p-value were not statistically significant. We would stop right there. So even if the means look like they're somewhat different than each other, we would not continue on if this overall F test did not show statistical significance. So there's a lot of information there. I know you're absorbing a lot, so we'll move on to the next topic. Thank you for joining me.